Right, so division. Right, so we've got the bill for 5 people at a restaurant is £73.55. They want to divide it equally. How much will each person pay? So we're dealing with division here. So the idea is you divide £73.55 by 5. Okay, so with this, because you're dividing, we're going to use the bus stop method. Okay, and set it up like that. You're dividing by 5, so put it on the outside. 5 into 7 goes once. 5 into 7 goes once, but there's 2 left over, so the 2 that's remaining, I write there, okay? So next to the 3, so we end up having 23 there. 5 into 23 goes 4 times, okay? And of course, 4 lots of 5 makes 20, so there's 3 remaining, so we write 3 there. Decimal point here, so I make sure there's decimal point here as well. 5 into 35 then goes 7 times, if you know your 5 times table, and there's nothing left over, and then 5 into 5 goes once. So they each pay £14.71. Okay, question 2. Now in this case here, we've got to divide by 14. Okay, now when you're dividing by quite a big number, 2-digit number, okay, it might help to actually write down your tables here, okay, and what I'm talking about, your 14 times tables. Now of course, none of us really know the 14 times table, so what you can do is just work it out. You've got 1 times 14 there, it's 14. 2 times 14, well, you're just adding on 14, aren't you? Add on 14 to that. 4 added on to that, you get 8. 10, then adding on, you get 20, so 28. Add 14 onto that, you get 42. Add 14 on, you get 56. So you can see now my 14 times table. 5 times 14 then is 70, 84, 98, okay, and 112, and so on, right? I might not need all of them, okay? We'll see now as we go through this. So 14, does it go into 4? Well, of course it doesn't it? So 49 we're looking at. 14 into 49, well, it goes into it, let's see how many times. Once, twice, 3 times, yeah? 3 times, and it won't go into it 4 times, because that's too much. So it goes into it 3 times, with 7 left over. Now I've got 70 there, and you can see, look, 70 is in the list. 1, 2, 3, 4, 5, it goes into it 5 times, so the answer there is given. Okay? Number 3, sorry. You've got a similar situation here now, but quite a large number, okay? And you're dividing by an even bigger number here, 27. Okay, it's much bigger than the last question, 14. So again, I revise this, your 27 times table. You don't know it, but you could keep on adding 27, okay? Might take a bit of time to do this, but it's well worth it. So keep on adding 27, okay? And you don't need to do too many. The most you'd have to do is 10, is down to 10 of them, okay? So then, so add on 27 to that, okay? Add on 27 to this, and so on, right? That might be enough there. We'll see now. Right, so 27 obviously doesn't go into 8, so 86. 27 into 86, so once, twice, 3 times, yeah? Takes you to 81, so 3 times, takes you 80 to 81, so there's 5 left over. 56, once, twice, and there's 2 left over, and that's quite nice, isn't it? Because then you're left with 27, and of course 27 goes into it once. So there's your answer, 3, 2, 1. Okay? Right, now this is interesting, when you're dividing by decimal, okay? When you divide by decimal, I wouldn't use the bus stop method, okay, because you get into a bit of a pickle. What I would do is I would write it as a fraction, okay? If we write it as a fraction, it comes out really easy, okay, when you write it as a fraction. So, of course, when you've got a fraction and a decimal involved, you might have been told by your teacher that, you know, this, you're not allowed to do this, okay? If you've been told that you're not allowed to do it, well, you're not allowed to have your answer left like this, okay? But what you can do, you are allowed to write as a fraction, so long as now we actually change this. If we think about it, here, we could change 0.1, okay, into a whole number, yeah? So we've written 50 over 0.1. I can scale this fraction, okay? I can scale it. I can make it the number on the bottom, so there's a whole number. Let's think, what could I multiply the bottom by to make it a whole number? In this case, if I multiply by 10, okay, it just becomes 1, doesn't it? 0.1 times 10 is 1. But if I multiply the bottom by 10, to make sure they're equal, I've got to times the top by 10 as well. So I get 500. So then I've got 500 divided by 1, which of course is just 500. Okay? Now, if you didn't quite get that, okay, I've got another one, a couple here which is similar. Okay? Now, in this case, again, you're dividing by decimal, so you might maybe not sure on how this works again. So write as a fraction, and then let's find an equivalent fraction. Let's scale this up. Now, let's think. We could times this by something, couldn't we? What could we times that by to make it a whole number? It's up to you. You could times it by 10. If I times it by 10, I'd get 2, wouldn't I? Or you could times it by 5. Okay, because 0.2 times 5, if you think of it, is just 1. Right? But of course, then if you times the bottom by 5, you've got to times the top by 5. So 200 times 5 is 1,000. 1,000 divided by 1 is just 1,000. Same situation here, 46. Right as a fraction, because you're dividing by decimal. Now in this case, think about what we could do here to scale this up. Times it by something. Times it by something. I'll ask my audience. Anybody in here would like to times it by something? 2. Excellent. Brilliant. So we can times it by 2, right? And we get 1, don't we? We times it by 2. But of course, you've got to times the top by 2. And you get 90, no, not 96, 92. Right? 92. Got to be careful there, 92. So the answer is 92. Now with this one now, number 7, okay, again you're dividing by decimal, so write as a fraction. Now in this case, again think of what we're doing. We need to scale it up, so we need to times it by 10. Okay, that's the only thing I can think of, times it by 10. And if we times it by 10, you get 9. Okay, and when you times something by 10, it gets 10 times bigger. So that 9 will go in the unit. So now what we need to do is times this by 10. And if you times everything by 10 here, it gets 10 times bigger, so you get 110.7. Now you're left with this, and you might be thinking, that doesn't help me. This doesn't help me here. But actually it does help, because now we've got it to a situation where even though there's a decimal on the top, we're dividing by a whole number. And when you divide by a whole number, it's really easy. Okay? Let's divide by a whole number. Okay, we can use the bus stop method. Okay, when you can always divide by a whole number using the bus stop method, even though this is a decimal here. So 9 into 1 doesn't go, so carry it. 9 into 11 goes once, and there's 2 left over. 9 into 20 goes twice, 2 left over, and there's a point here. And then 9 into 27 goes 3 times. It's a 12.3, and we're done. Right, last one on dividing here. So we write this as a fraction, and now just think, what can I times this by here? And if I times it by 10, think about it, times 0.05 by 10 doesn't really help me, because I still end up with a decimal. Okay? Okay, I mean, I suppose then you could deal with 0.5, but if I times it by 100, of course, timesing it by 100 make it 100 times bigger, so that 5 will end up in the units. So in the bottom then, you just get 5. Times the top by 100, and you get 500. And 500 divided by 5 is just 100. Job done.